Hello, everyone, and welcome to this bonus episode of the Process Automation Podcast from ABB. Before we dive into our upcoming episode on how the pulp and paper industry is transforming itself into a catalyst for bioenergy and bio-innovation, we are going to look at the bigger picture and explore other pathways for fibre-based innovations. Because fibre is no longer just about paper. Across the industry, wood and cellulose are being reimagined into advanced biomaterials, sustainable textiles, and bio-based energy sources. And these developments are opening up new possibilities for circular production, reduced reliance on fossil energy sources, and entirely new markets. And so in our bonus episode today, we are going to be asking, how is this shift happening? And what role is technology playing in enabling it? And to do this, I am going to be joined by Stefan Thorburn, Senior Principal Scientist at ABB Corporate Research. I'm Fran Scott, and this is the Process Automation Podcast from ABB. So Stefan, just to start, how do you view the future of wood as a raw material in the pulp and paper industry?
I think that wood will be a very important feedstock for the future, not only for making pulp and paper. We see opportunities to make stronger wood, something called self-densification. And that can make a piece of wood as strong as aluminium. And this is happening in university labs. At the same time, we see the other side that we talk a lot about deforestation and the living animals that you have there, that they are a bit stressed when we cut down the forest. So that will be the other side, how we as society decide to use the forests. And here there are a number of alternatives. For instance, if we grow up a new type of wood or, as we see now, bamboo, to provide the feedstock for the pulp and paper industry, we will see that there will be a change in the raw materials that we have coming into the pulp and paper industry.
Interesting. So what are the most promising bio-based innovations that can replace materials that have previously relied on other fuels, let's call them?
I cannot rank them, but there are a number that are quite interesting to follow. And one is lignin, and you can do quite a lot around lignin. We see use where you use lignin and convert it so you can have it as a fill-in when you do plastics. And that will be a way of reducing the fossil material that we today use in plastics. To give you a reference, in Sweden we have around 10 million tons of lignin every year, and we are using 1 million tons of plastics. So the source of having lignin as a fill-in is quite good. Basically today we are burning all of this lignin to provide heat. And this is then a possibility to change. We also see ways of making textile, viscose and other things are possible to develop. And this could then fill in other areas where we today use fossil. And I would like to raise a third area here, and that is for batteries. If you study this, you will see that around 40% of a battery, if I recall correctly, is actually carbon. It's the anode part where you sort of extract electrons when you're charging the battery. And today, most of this is taken either from mining or from the fossil industry. But we see companies now that are trying to convert lignin to carbon and replace that into the battery. And here, since graphite or the carbon part in the batteries is one bottleneck, we can possibly see a development where we take lignin and convert it to a battery material instead.
So, Stefan, what is lignin and where does that come from?
It's a part of the tree, basically the glue, you can say. You have cellulose, then you have hemicellulose and lignin. And lignin, you don't want to have that in the paper because it is like a glue, and you take that away in the process. And so far, the most common use has been to burn it up. And we now think that there are better ways of doing that. But in order to replace the heat that we get from lignin, we need to find another way of producing all the steam that you need for the paper process. And it's actually here where the electrification comes in, because that is another area making a very fast and dramatic change. We now see growth for solar and wind, which is also very quick. If we go back 3 years, we have doubled the amount of solar. And if you now look 3 years ahead, again, we will double the solar production. The introduction of solar and wind will also influence the energy market. When you have a lot of solar or a lot of wind, the electrical prices will actually go down. And we see more and more hours with zero or negative electric prices. So if you now produce steam to make paper and also sell to the electrical grid, you can imagine that it's not so attractive to sell to a market where you actually have to pay to get electricity out. So what we think is that when the prices are becoming more volatile and you also see long periods with very low prices, the pulp and paper industry will sort of try to make use of this and replace some of the heat need that they have and electrify that part. So basically electrify the heat, and that you get out lignin, and you can do something with more value than just burning the lignin. So these are connected.
Absolutely. And with the negative pricing, obviously that is when you have enough electricity to then sell it back to the electricity grid. Is that correct?
Yeah. It is when you produce too much electricity and the customers don't want to have the products.
Understood. So it's basically diversification at its finest. And with the pulp and paper industry, it's so much more than pulp and paper. You're looking at changing the plastics industry, the clothing industry, even the battery industry. So what technology is making all of this possible?
I think the newest or the thing that has changed most the last couple of years in this respect is that we now see heat pumps that can produce steam up to around 200 degrees or so to the temperatures you need in a pulp and paper plant. Or you can also install electric boilers that provide this. So we are sort of thinking that there is a change now, that some of the recovery boiler burning will be replaced by electric heating. And as I said, the output will be more biomolecules that you can actually convert to something else.
Understood. And in terms of the technology, it's not just, I suppose, how you can generate the heat in a different way, but there's going to be different shifts, both to do with technology and working practices and policy. So what sort of shifts are needed within the plants in order to make these new materials that we're working on?
I think that this is a quite the big hurdle here, I think, is that there are several things that has to happen at the same time. You should have access to cheap electricity. You shall extract from the waste flows that you have in your process. You shall convert that to something that could be a new market. And here I would like to point out one opportunity for the pulp and paper industry, because we know that it is associated with a lot of shipping all over the world. And the marine industry also see a quest for their next fuel. And here we have methanol as one opportunity. So I would say that if you are a pulp and paper company that produce methanol for your own shipping, that would sort of risk reduce the transport costs for the future. And we can see that we can develop this step by step. One problem with doing some of these conversions is that in addition to having the new path of your product, some of these also will require more electricity.
Could we focus in on biofuel just for a moment? And when it comes to biofuels, how do they compare both in terms of cost and performance in comparison to other fuels?
The things I have seen is that the cost of various biofuels will be related to the cost of carbon emission. And if, like we are doing in the European Union, are going to sort of raise the cost for carbon emission, the fuel cost of bio-based sourced material will actually become more competitive, I think. But there are also here there are quite a few interesting technologies for the future, still in quite low TRL. We can, for instance, do syngas, that you sort of split up the waste or the sludge so far that you have carbon monoxide. And then you can add hydrogen, and then you can start to build up the chemicals as we are doing today from fossil gas. In addition to the steam reforming and the methods that are used in the traditional industry, we actually see other paths of doing this conversion. It could be biochemical, where you actually have microbes converting this. And there are companies now taking this syngas and do fuel for the air industry. There are electrochemical ways of converting this. Other startups are trying to do this in a similar way as a hydrogen electrolyzer, but you put in a little bit more in the cell and you can get methanol or other stuff out directly. Still startup companies and not fully products yet. But the combination here with the pulp and paper industry, which has concentrated access to, for instance, CO2 and also have a lot of process knowledge. If we now combine this with these new startup companies, we can build organically from smaller volumes a completely new way of providing the chemicals that we need in the society. We have talked mostly on this burning of biomass. We also have the paper and tissue industry, where we today have seen numbers of 100 terawatt hours of heat. And this is used to dry the paper. And here, if we can start to electrify that part, we immediately get a quick reduction of the CO2 emissions. And with the changes we see in the electrical grid, with the renewables and so on, we can possibly imagine that we can begin to fill in the fossil burning with the electric boilers and do a transition where you have very, very low energy costs. At the same time, you are saving CO2.
Stefan, what is TRL?
Yeah, it stands for Technology Readiness Level, and it's a way for us to point out the maturity of a product. So it starts with 0 and it goes to 9 when you have a ready product, you can say.
Gosh, so when it comes to biofuel, there's so many different ways to look at it, isn't there? In terms of, yes, it can save money because you are not subjected to the same tax that if you're using fossil fuels, but there's also so many different ways to make it. But when I look at the pulp and paper industry, one of the many genius things I see is that you're utilizing waste products. And so is this using waste products being widely adopted throughout the industry and elsewhere?
To some extent, we are using the waste, but I also think that there's a lot of landfill. I think that we shall combine this with the recycling of paper in general in the society. By doing this, we are saving both energy and water, actually. Pulp and paper is consuming a lot of water, and this will also be an important factor. But generally, I think that the waste flows that we are seeing, they have an advantage because we can convert the waste to good products when we, for instance, have cheap electricity. So taking care of the waste with periods with quite low electricity prices would actually be an opportunity, I would say. So this will then give you additional income, but you are avoiding the highest energy costs.
So, Stefan, we've touched on this throughout, but it seems that because now electrification is coming to the forefront, as it is with many planet-friendly alternatives, do you think it's because we're getting our head around implementing electrification and the availability of renewable electricity sources that means that this is happening now? And how do you see this progressing in the future, and what barriers there might be to it progressing?
In general, I think that the society, some part of the society has woken up to a situation where we realize that we can electrify a car, we can electrify a big truck, we can implement heat pumps, and suddenly it's sort of open up a future where we don't need to have this NOx and SOx emissions and so on. And I think that people are realizing that, this can develop into also other areas. Then also combine this with the possibility to capture more solar and wind in combination with batteries. We actually have ended up in a situation where we add solar, wind, and batteries faster than the load growth for the first time. So suddenly, this could be a solution for the carbon emissions that we see. And I would like to add another thing that could be of interest in general. And if you have a boiler, it has a lot of additional heat losses in the surroundings. So people that are working there, they actually have a hotter environment. And if you convert this to an electric boiler, we can add as much energy or power as we want in order to keep the temperature at that level. So instead of burning with 1000 degrees and everything that is heated up around this, we provide the steam at the temperature we need. And these are additional benefits which we haven't yet considered, I think. Because if we can also give a better working environment for the people and still provide pulp and paper with similar costs, this would be a benefit in general, I think. So the full electrification slowly open up and show us other things that we didn't think about.
So, Stefan, we've covered a lot. What are you most excited about the pulp and paper industry for the future?
I'm seeing pulp and paper as a very good arena for the transformation we see both on the energy side, on the material side. It is connected to something we need every day, most of us, and we can also see a lot of additional benefits from the biomass that we today are burning and convert this to something good for the future.
So you're making an impact even outside your industry.
Yes.
A huge thank you to our guest, Stefan. And if you want to get involved and join us as an expert, follow the link to ABB's website in the episode description, where you can let us know your domain of expertise. I'm Fran Scott, and the Process Automation Podcast is a fresh air production for ABB. Follow now for free wherever you get your podcasts so you never miss an episode.